Picture yourself by a glowing campfire, the night air crisp and cool around you. The gentle crackle of burning wood fills your ears, and the soft orange glow dances across the faces of your friends. You stretch your hands out, feeling the comforting warmth that pushes back the chill of the evening. There's something magical about this moment, a sense of togetherness and peace. The flickering light and cozy heat have brought people together for ages, creating memories, sparking laughter, and inspiring stories passed down through generations. But have you ever wondered what's really happening in that pile of burning wood? What's the secret behind those mesmerizing flames? Why does fire feel so inviting and warm from a distance, yet can burn your skin if you get too close? It might seem like magic, but it's actually pure science at work. The answer lies in a rapid chemical reaction called combustion, which transforms wood and oxygen into energy, heat, and light. When wood burns, its atoms and molecules break apart and rearrange, releasing energy that we experience as both heat and the beautiful glow of fire. This process has fascinated humans for centuries, connecting us to a long history of curiosity, discovery, and the quest to understand the world around us. So, let's take a closer look and dive into the science behind why fire is hot and how it shapes our experiences. Are you ready for a journey into the fascinating world of chemistry, energy, and the wonders of fire? Imagine the campfire as a wild dance party for molecules, where every spark is an invitation to join the fun. The flames flicker and leap, setting the stage for a spectacular show of chemistry in action. Wood is made of cellulose, long, twisting chains of carbon, hydrogen, and oxygen atoms all linked together. These molecules are packed tightly in the wood, just waiting for the right moment to break free and move. Oxygen from the air is the eager dance partner, swirling in and around the wood, searching for a chance to join the action and create something new. Heat starts the party, breaking the strong bonds in the wood and letting the atoms mingle and mix. The energy from the match or lighter is like the opening beat that gets everyone moving. Carbon atoms pair up with oxygen to form carbon dioxide, while hydrogen atoms find oxygen partners to create water vapor. These new molecules swirl away as smoke and steam, rising into the night sky. This fast, energetic chemical reaction, combustion, releases a burst of energy with every step, fueling the fire's heat and brilliant light. The wood acts as fuel, oxygen keeps the reaction going strong, and the energy pours out as warmth and a mesmerizing glow that draws everyone closer. As long as there's wood to burn and air to breathe, the chemical dance continues, keeping the fire alive and the party going. Each new bond that forms releases even more energy, fueling the next round of reactions and making the flames leap higher. That's the chain reaction behind every campfire's magical glow, a never-ending chemical dance party lighting up the night. Let's zoom in on the energy at play. Chemical bonds are like strong magnets. It takes energy to break them. The heat from the fire breaks these bonds in wood, using up some energy at first. But when atoms form new bonds with oxygen, they release even more energy. This profit is what we feel as heat and see as light. The energy was stored in the wood's chemical bonds all along. Combustion unlocks that energy, sending it out to warm everything nearby. Every campfire is a dramatic transformation of stored energy into heat and light. That's the science behind the warmth you feel. Have you ever wondered how the fire's heat actually reaches you when you're sitting by a campfire? It's not just magic. There's real science at work, and it's happening all around you. The main way is through thermal radiation, energy that travels as invisible infrared waves, much like the sunlight that warms your skin on a bright day. Even if you're not right next to the flames, these waves can cross the space between you and the fire, carrying energy directly to you. When these infrared waves hit your skin, they make the molecules in your body vibrate faster. That's what you sense as warmth. It's a direct transfer of energy, and it happens almost instantly, letting you feel the fire's heat even from a distance. But that's not the only way heat travels. There's also convection, where hot air above the fire rises and cooler air rushes in to take its place. This creates a constant flow or cycle of moving air that helps spread the warmth. If you hold your hands above the fire, you'll feel a strong upward blast of hot air. That's convection in action, carrying heat away from the flames and into the air around you. Radiation and convection work together, spreading the fire's energy in different ways. Radiation sends heat straight to you, while convection moves warm air around, making the whole area feel cozy. That's why you can feel warm sitting by a campfire, even if you're not touching it or sitting right next to the flames. The heat finds its way to you through both air and space. The fire's energy moves quickly, traveling through the air and across open space, reaching you in just moments. It's a powerful reminder of how energy moves in our world. In fact, it's the very same principle that lets us feel the sun's warmth from millions of miles away, even though there's nothing but empty space in between. So next time you're by a fire, take a moment to notice how the heat travels to you, through invisible waves and moving air, all working together. It's science in action, right before your eyes, making every campfire a lesson in the wonders of physics. Next time you enjoy a campfire, remember, you're witnessing chemistry and physics in action. The warmth you feel is energy released from chemical bonds, carried to you by radiation and convection. Understanding the science makes the experience even more amazing. Science isn't just in labs, it's everywhere, in your kitchen, the sky, and even your own body. Every question you ask is a step toward discovery. Stay curious, keep exploring, and never lose your sense of wonder. The world is full of incredible science waiting for you to notice. Science is for everyone, especially you.